Welcome back to Bal Vigyan Bharati with Vilas Sarkar. As you know, we are progressing on numerical problem solution in fluid statistics. There we have reached till 8. Now onwards, I will move on to problem 9. The force acting on a window, the force acting on a window of area 50 centimeter cross 50 centimeter of a submarine at a depth of 2000 meter in an ocean the which is that angle of the page is maintained at sea level at 200 pressure is okay. Ocean, the internal, okay, the internal pressure of which is maintained at sea level, atmospheric pressure, pressure. So you have to find the force acting on a window if such condition arises. Density of seawater is given as 10 cube kg per meter cube, and g, the gravitational acceleration, is 10 meter per second square. Okay, so let me present in a sketch. Let's say this may be the sea, this is the bottom of the sea. There is a submarine, let it be of this set. Okay, so there is a window of size 50 by 50. Okay, and submarine is at a depth of 2000 meter per ocean. So with respect to the height, that window and this is almost in the same plane, so we can assume the height of the submarine, we can assume depth up to the top part of the window. That much assumptions, or the you can say the that much correction we can take. Okay, we need not to be so much worried. So as this is given 2000 meter almost 2 kilometer, and with respect to the dimension of the submarine and the window is almost negligible. If I take from this side or this side, negligible, so we can take that height is, or the height of the thing is as 2000 meter. from the sea level. The pressure inside, if I take, it is P1, it is said to be maintained at what? The internal pressure is of which is maintained at sea level atmospheric pressure. So sea level atmospheric pressure, that means that atmospheric pressure itself, so P at a, so that is equal to 1 atmospheric pressure at sea level. Okay, so inside the P1 is 1 atmospheric pressure, 1 atm or 1 bar with the approximation. Okay. So there is a pressure is P atmospheric, inside also P atmospheric, and so then the window, if I take, this is a cross section of the window, so from inside, if I say this part is inside, from inside the force is created, F1 is created by the pressure P1 inside into the cross section, and from the other side the force which is created due to the atmospheric pressure P0 plus the pressure due to the height h rho g into the cross section. Okay, so as this force is a vector and two opposite forces are acting on it, the resultant force will be the difference between this whichever is more, and that the direction will be, the resultant direction will be in the direction of the force which is more, but the ultimate, the value of this will be the difference between the two, because these are acting in the opposite direction. So now this is P1 is nothing but P0, that means P atmospheric, this is, so what is the difference? If I put it, because both are acting on a same cross section area, so P0 plus h rho g minus P0 whole into A. So that means if inside pressure is maintained at atmospheric, so atmospheric pressure, that is a part of this F2, will also nullify each other. So ultimately h rho g into A will be the force acting. You can see every data is available, h is known, and rho, that is the density of the sea water, is given, g you know, cross section you can, so you can put the value. I will put the value, so this you understand. So I will rub it out for the space required to calculate the resultant force. F2 minus F1 is equal to, h is given in meter 2000, okay, and rho is given in also SI unit, no issue, 10 to the power 3 into g is 10, that also in SI unit, and the cross section is given in centimeter, so that means I have to make it in SI unit. So centimeter to meter is divided by 100, so as equals square meter. So ultimately you need not to worry, because this is force, it will come in Newton, because all are in SI units. So ultimately the calculation after all this calculation of the unit, unit will come in Newton. Okay, you can try it with your own sense also. Okay, so that will come in Newton. And now 1 2 3 1 2 3 1 1, so everything is cancelled. The only remaining is 50 into 50, 5 into 5 into 2, so that means 5 into 5 means 25, 25 into 2, 25 into 2, 50. So let me write all the remaining one. This together is 10 to the power 4 into 5 into 5, 250. So ultimately 500, 5 will remain, 10 to the power 2, 10 to the power 10 to the power 4, 10 to the power 6 Newton. So this is the force acting on the glass, the resultant force is acting on the glass. Okay, fine. So I will uh, no confusion in that. Yes, fine. I've converted already the centimeter into meter. Cross section I've found here. So this pressure into fine. So I'll move on to the problem number 10. Four vessels A, B, C and D have different shapes and hold different amount of water which of the following is correct. So let me draw the diagram, then I will come to the condition that has to be judged whether the condition is correct. So these are the different shapes. These are open-ended container. These are of different shapes. All are having different shapes, hold different amount of water. That means their overall volumes are different. If I consider this height, all are in same plane, different shapes. So whatever this will contain different, this will contain different, this is up to so they are contain different. But if I pour water, that will fill up to same level. Okay. Now the points which are considered to be at the point, let's say at the line of the horizontal line where the each container's bottom part is touching the one horizontal line that is crossing across, and there we are taking 4 points E, F and G, H. So 4 vessels are given of different shapes, and now condition could be anything, but what will be the correct condition for this? That if I consider the pressure here, pressure at E, this is just a logical question, is now these are occupying same height everywhere. This also H, up to this also H, this also will be H. Okay. Shapes may be different, but as liquid will be poured, hold different amount of water, means this the volume of this is different, but the volume is different doesn't mean so that will carry a different height of water, because volume is different, that will affect the amount of water it contains, but everything will be same, as because this volume here in first is equal to h into the cross section area of this first. So volume will be definitely, but h can be same. So h is same, so PE will be the, or everywhere the atmospheric pressure at the top are same. Okay, so the P0 plus H, rho and G. Now this is not changing, this is not changing, this is not changing. So everywhere, the every point, all the pressure must be equal if they are considered in a same horizontal line. But this could be, these are not that it should be of this line. If I draw a parallel to the base and I take some respective dots just below the container, then also if I take the height of this point, these are all in same horizontal line. So whatever the delta H will increase due to the shift will be affected in the same way in this formula. That means H plus delta H of height, instead of H we will consider, but P, if instead of P, that could be a different point, P dash we can take. So there, with that reference, the other one also will be increased in the same way. So correct answer, if this option has been given, so this will be your correct answer. So we have taught this in several times during the theory portion. So this is a logical one, and this is the answer, that every pressure on a same horizontal line does not depend on the shape, depends on the height of the thing. So number 11, the U2, the U tube, this is a tube in a shape of U. In figure contain, I will draw the figure once I will complete this sum. Means once I write all the description, then I will draw the figure again. The U2 in figure contains two different liquids, in static equilibrium, water in the right arm, and oil in oil of unknown density rho x in the left. If L is equal to 135 millimeter and D is equal to 15 millimeter density of the oil is how much? So let me draw the U2. This is open-ended U2, both endeds are open. Okay, so let it be like that. And oil is poured, let's say oil is marked with a hash line, this one. After that, and other arm, water, if I consider it has reached up to this, oil is this is separated by okay, so this kind of slant line, this is marked as oil, this kind of slant line is marked as water. Okay, and the level difference at the top where water level ends and where oil level ends, having difference of small d, and level where oil at the bottom of the bottom level of the oil, and the difference of the we can say this part is given as L. So from there you can very much able to clear that this is the bottom part of the oil. From there a horizontal line is marked, and this horizontal line is representing the level in a steady state, means this is after it become a liquid in static equilibrium. This is the condition of the fluid column. It is stable somewhere like this, and the dimension is given as this is your L, this is your, this part is D. So this part if I take, this part if I take, this is your D. Any other information? No. Now moving on to the problem to solve it. This is D, it is given as 15, and this is L, L is given as 135. So I am putting all the dimension here in itself so that calculation or understanding will be better. So this is U2. The different fluid is being poured into different arm. So due to their density difference, after being in the static equilibrium, oil level where it is ending at the open end, that is having a height advantage over the water of D. So there the both liquids are in equilibrium. So the one thumb rule for any this kind of U-tube problem, the thumb rule is that the fluid pressure, I am not talking about the liquid, rather I am talking about the fluid. The fluid pressure, this is to be very much understood, and is always you have to keep in mind, so that every problem you can treat basis on this concept. This concept is very much universal and unique, and if you follow this, I can guarantee you will not make any mistake anywhere in exam. What is that? The fluid pressure at any horizontal, the fluid pressure no, not that. The fluid pressure, the fluid pressure is same for same fluid pressure is same for same fluid in a horizontal line. Whether I am clear to you or not, fluid pressure is same for same fluid in a horizontal line. Now, if I take this example and try to correlate this statement, fluid pressure is same. I'm talking about the fluid pressure is same when the fluid is same itself. So that means where you can find the fluid it is same. This part it is a different fluid. This part is not matching. So if I remove it, this part from there to there, the fluid is same. So this is matching the same fluid. Okay. Now same fluid exists in this horizontal line. So in a horizontal line, this is a horizontal line. If I divide the whole thing with this horizontal line, where this part only contains same fluid. So if I contain the same fluid, the fluid pressure is same. Where? In that horizontal line. If I consider this horizontal line, and this is cutting these two arms in these 2 points. So it could be more finer if I say the fluid pressure is same for same fluid in a horizontal line cutting the fluid pressure is same for same fluid in the same fluid at 2 points where a horizontal line cutting 2 arms of the U-tube. This will be more elaborate and clear. So now fluid pressure is same for same fluid at 2 points where a horizontal line cutting 2 arms of the U-tube. So this is horizontal line cutting 2 arms of the U-tube at this 2 point where the liquid is same, have same pressure. Now if I say there is pressure P1, there is pressure P2, so that means P1 is equal to P2. If you can establish this one at what point your pressure is same, then further the job will be easier. Now if I want to calculate the pressure at this point P1, what are the pressure? This is atmospheric pressure P0 and the pressure due to the oil level. So this is P0 plus, let's say this is H1. Okay, so H1 and the density of oil into G. This part is over P1. What is about P2? Now same atmospheric pressure here on the surface of the water here, P0 plus, for it the height is this much, H2, let's say. So H2 density of water into G. This will be the equation. Now this is not taking part in the calculation. What are the things? Now if I calculate, this also will cancel. So what is remaining? H1 into density of oil, H2 into density of water. This is the thing remaining. Now I'll rub it out because I understand you have read it well. Now, what is H1? What is H1? How will you get it? This part is 150, this is L1, so H1 is nothing but L plus D, and oil density is given somewhere. It is unknown density rho x, so rho x is there. On the other side, what is H2? The water level above this horizontal line is this much only. H2 is your L, and rho of water, as because this in all in CGS, this is CGS, this is CGS. So if I take the density of water, which is which can be taken as 1 gram per centimeter cube, so in that unit also this density will come. If I know all this, so rho x is equal to L by L plus D, so that is equal to 135 plus 135 plus 15, isn't it? So 135 by 150, 5257 530, then further 39310, so that is equal to 0.9. 0.9 what will be the unit? As I have taken it is gram in centimeter cube for water, this will be the value 0.9 gram per. So this is the value of the unknown density. Okay, fine. I'll move on to the problem number 12. Problem number 12. In a YouTube experiment, in a YouTube experiment, a column AB of water is balanced by a column CD of paraffin. The relative density of paraffin is how much? Okay. Now let me draw the YouTube for you. The YouTube that given in the sum is written as means described as this with the two arm, and it is merged with this. Okay, fine. So the U2 has a column of AB. This seems to be AB, A and B of height. Let's say this is described as H2 height, which is having water. This is water, and the paraffin, the other arm. So this is the arm, and this is the paraffin given. Now the water and paraffin are immiscible, So they are not mixing each other. So they are separated bounds by a boundary here. Okay, so there the two densities are different, and the layer is able to seen differently. Okay, so this is the part given by C and D, and this is your, let's say the height is H1. Okay, fine. So this is your paraffin. This given is like that only. Okay. Now in drawing, it has shown that the height of this is less than water. That means, what is that? The paraffin density is more than water. So that's why now up to this, where the paraffin ends, up to this water level is maintaining from there to this. Only this part is paraffin. Let's say I'm just making it has. This is paraffin. So that means this much of water column is balancing this much of paraffin. Now, as per the earlier understanding, we said the pressure at one horizontal line that is passing through the two arms of the U2, which contains the same fluid, will be at same pressure. That means, this case, if dB be the line, which is a horizontal line passing through this two arm of the U2, where the liquid here in this part is only water. So at point, so you can say the pressure at D equal to pressure at B. This we can say. Okay. Now if it is so, now you know all are the other things, because this is the this is open tube, so atmospheric pressure will act on this, on the free surface. So this is PD. If I want to consider, it is P0 plus H1 and paraffin, density of paraffin into G is equal to P0 plus H2 density of water into G. This will not participate in the calculation. Then our remaining is H1 H2. So G also will not participate after removing this. So H1 paraffin density is equal to H2 density of water. Now the relative density of paraffin, that I have to find how much. Okay. So the relative density of paraffin is what? The relative density of anything is what? The density of the object, density of the object by the density of water, or the density means rho of the object, rho of water. This is the case. Now in this case, object is paraffin, means the liquid is paraffin, whether it is paraffin or something else, but this case it is paraffin. So your relative density can be understood if I can calculate this ratio. Now if I bring this, I will get H2 by H1. So that means the relative density, which is represent as per the definition, is the density of the paraffin by the density of the water, can be represented here as H2 by H1. That means the height of the expression in the column of AB column is expressed by H2 and CD column is represented by H1. So this is the relation we will get for the relative density of the paraffin. Understood? So here I will end this session. In the next session I will move on to the problem number 13. So thank you for now.